Hello, everyone, and welcome once again to our Fronius webinar series. These are webinar series dedicated for, of course, not restricted to a sub-Saharan region. These are webinars where we discuss Fronius products and solutions. And today we shall be discussing heating and e-mobility solutions with Fronius Inverters. Then your presenters today are, of course, myself, Cyprian Okolo. I am the Technical Sales Advisor for the Western Africa region. And to do this with me today is Byron Kotter. Byron is the Technical Sales Advisor for the Southern Africa region. So let's quickly have a look at the agenda for today. So we shall be discussing sector coupling, where we discuss the integration of the heating and e-mobility solution. And then, of course, we go through to Fronius Energy Flow Management, heating solutions with the Fronius Ohmpilot. Byron will be coming in and to discuss the Fronius Wattpilot and how it can be used to implement e-mobility, and of course, discussing its relationship with PV. He'll also be touching on load balancing and then be giving us further information afterwards. So before we start this, we encourage you to feel free to ask questions during the webinar by using the chat function. We shall endeavor on our side to answer these questions during the webinar. In the case where, probably due to time constraints, we can't do so, we will, of course, communicate to you via email. Your opinion, of course, is important because it matters to us. Please feel free to give us your feedback on the content of our webinars. Thank you. So let's continue to first subtopic of the day, which is sector coupling. Yes, it's a well-known fact now that we can easily make use of power from the sun and then to generate electricity that we use to serve our base loads. And then, of course, charge once we have surplus, use it to charge our batteries, and then make use of this charge for later use, of course, to supply our base loads. But then it really doesn't stop there. In Fronius, we, of course, have the possibility of integrating other sectors when it comes to sectors talking about heating, and then, of course, e-mobility, which, of course, forms the topic of today's webinar. So we shall be looking at how we can make use of Fronius inverters to implement heating solutions via thermal storage, and then, of course, e-mobility, using it to charge our electric vehicles, which can be electric cars, motorbikes, or even bicycles. Great. And then how best to do so without, apart from having a perspective to this. So it is our vision to achieve 100% electrification, especially when it comes to private households. And then using a reference for 4-person household, their consumption analysis. So this household, this reference, we have the use of 1 diesel car and gas heating, which gobs up a total of about 29,000 kilowatt hour per year, with 15,000 kilowatt hour going to gas heating, and then 9,000 kilowatt hour accounted for a diesel car, of course, with a base load of 5 kilowatts per year. With the implementation of the heating and e-mobility solution from Fronius, we can actually bring down this total energy consumption to about 14,000 kilowatt hour per year, thereby saving more than 50% in terms of energy savings, as you can see. So in order to achieve this, it is, of course, important to know how to implement the energy flow management offered by Fronius. This is achieved by, of course, monitoring with the use of the Fronius inverter and the smart meter, of course, monitoring your consumption, and then noting how your the energy consumption profile is. So once this is noted, just like the sample or the example we have here, we endeavor to ensure that we make use of the surplus energy, as you can see with the region in this light gray colored region. So in order to push all our consumption within this PV production region, and with this maximize our self-consumption. Of course, by using it to switching of heavy loads like air conditioners, heat pumps, cool pumps, and then of course marrying it with other sectors to achieve a perfect energy flow management. I believe Byron will be mentioning something on this later on, but then just before then, it is with this we can actually achieve perfect energy sector integration by, of course, achieving storage, thermal heating solution, and then, of course, e-mobility solution. And then this can actually be prioritized, meaning that you can prioritize the charging of your battery. Say, for instance, you can prioritize it to charge your battery to about the state of charge of about 50 or 70%, for example. And then once this is achieved, the surplus energy will now be shifted to the Ohmpilot that will now be used to trigger hot water generation. And then probably set it to achieve a temperature of about 60 degrees Celsius, hot water. And then this can now be switched to the Wattpilot afterwards to help in charging your batteries. So more will be discussed on this in the subsequent slides. So moving forward, this can actually be achieved by making use of the 4 digital input-output ports available or integrated in our inverters, that is for the Gen 24 and of course the snap inverters. So for the Gen 24, it's available as the Pilot, and then for the data manager, it's available as the data manager. That is for snap inverters, of course. Good. So with these digital input-output ports, we can configure them as output ports to be able to turn on with the use of multifunctional relays to turn on smart grid ready heat pumps, pool pumps, and even air conditioners. This, of course, is discussed in detail in other webinars, so we encourage you to check our YouTube channel for more details about this. So, but just basically to show you how they're integrated in our snap inverters and in on the Pilot, the usually integrated in all our Gen 24 and Tauro inverters. Good. Focusing now on heating solutions, we would want to ask the question, why heat with PV power? Well, it's actually a no-brainer because it's easy. It's easily retrofitable with electric hot water boilers. And then in terms of making use of IR or infrared panels, so you don't need to incorporate or install any additional water tubes. No, all you need to do is just to do your electrical connections to your infrared panels, and then that's basically it. It's, of course, economical, whereby saving you a lot in terms of heating materials. It extends the lifespan of the main heating source, requires less maintenance, and of course ensures the highest self-consumption rates. In terms of investment cost, it's quite low with in comparison to other solar thermal systems and other heat sources. You get to emit no emissions per se, as you are able to generate your hot water with surplus energy from the sun. And in terms of key performance highlights, when it comes to self-consumption, cost effectiveness, energy self-sufficiency, and then ease of installation, we have them all in high marks when it comes to the implementation of our heating solution. So that now brings me to the introduction of the accessory or the device implemented to achieve this particular solution, and that's the Fronius Ohmpilot. So this is basically a device that it's used to achieve stepless control of heating rods from 0 to 9 kilowatts and beyond. Would get more details in subsequent slide. So you can actually have it in single or the three-phase connections. So for single phase, it can go up from 300 watts to 3 kilowatts, and then for three phases from 900 watts to 9 kilowatts. It can also be used to control two heating rods, and then can be visualized. The results can be visualized and monitored on database that is the Fronius SolarWeb. Of course, it has different options for communication, be it wireless LAN, LAN, or even remote bus RTU. So, like I said, it is basically used specifically for ohmic loads, for purely resistive loads. That is loads like underfloor heating, infrared panels, and then in most cases where they're being applied is in the use to activate heating rods in boilers. So you can have them in, like I mentioned earlier on the previous slide, 3 kilowatts for single phase, 9 kilowatts for three phase, can also be used to control up to 18 kilowatts heating rods. I'll also be explaining this in the subsequent slide. So with this, you will be able to generate hot water with the power of the sun for all year round. That is all through the different seasons of the year, be it winter, spring, summer, or even fall. And this cannot, depending on the region, of course, you can actually have this exceeding 8 months. But for regions that tends to, have a period of winter where you have limited solar energy, you could actually have an average of 8 months generation of hot water with the surplus power of the sun. So let's have a look at how this basically works with, of course, the integration of the Ohmpilot in the pre-existing heat generation system. As you can see here, with the use of a primary heating system, it could be gas, it could be coal, it could be whatever, it's generation source, then this can, of course, be substituted or complemented, as the case may be, with the use of the Fronius Ohmpilot. And then with this, you will be able to generate the same hot water for your hot water usage by simply implementing the Ohmpilot, and then, of course, making it to use the surplus power from the sun and then to generate the hot water. So, and this, of course, leads to less operation period of your main heating source, and then it, of course, extend its lifetime. Yeah, so by so doing, you, of course, have lesser thermal loss. Good. So coming to the hot water generation with either one or two heating rods, this is of course possible. And then this is basically how the schematic is. So you can have one heating rod at the top and then one heating rod at the bottom. The heating rod at the top, basically you can actually have that triggered in order to generate hot water for immediate use. And then this could also come just to complement the heating rod on top. So what this does is basically to implement a simple law of physics, because cold water is basically denser than hot water. So if you heat the water from the top and then you have your usage valve here, you can immediately use the hot water that's been generated by the heating rod. If you had this one activated, it will have to get warm, then the cold water here would now have to come down. So this, of course, takes a lot of time and energy. So for immediate use, you can actually have one heating rod, the one on top, activated for immediate use if the usage hose or faucet is here. And then that, of course, gives you the luxury, per se, of immediate use of the hot water generated from the heating rod. So that's basically it. And then going further, you can actually have it installed externally. Yeah, so in the case where you have a system that has an external flow heater, as you can see from this schematic, so you can have your Fronius Ohmpilot with the heating rod connected. So this generates the hot water, and then via a pump, you're able to pump the hot water into the hot water tank or boiler, as the case may be, as you can see. Good. So, yeah, so in terms of energy demand, we can see that from this reference that in the case where the generation of hot water for a 300-liter hot water boiler with the flow temperature of 10 degrees Celsius, it is possible to generate hot water at 40 degrees Celsius with a volume to a volume of about 150 liters with 5 kilowatts 5 kilowatt hour energy. Okay, and then this is usually the minimum energy required for cloudy days. Excuse me. Then in terms of 300 liters, this can of course be generated by 17 kilowatt hour with to about temperature of about 60 degrees Celsius. And this is usually the maximum energy required on sunny days. So in terms of own consumption values, using Austria as an example for the same reference case, we have the possibility of controlling your air conditioner and then having a self-consumption rate of about 10% with just about 5 kilowatts peak of PV power. The same 5 kilowatts of peak 5 kilowatts peak of PV power can, of course, be used when load management is implemented to control your heat pump, and then, of course, have up to 20% and above of self-consumption rate. And then this can actually get up to 50% when you now implement it using the same capacity of PV power to generate hot water for a 500-liter storage. Good. So now let's quickly look at the installation of Ohmpilot. So having a quick look at this, the required components are usually the snap inverter with the data manager or the Gen 24 inverter with the pilot. So the data manager and the pilot are essential for the implementation of the Fronius Ohmpilot, because that's where you'd have the communication interface. Of course, you would need your smart meter to be able to give both consumption and production monitoring and sensing. You would, of course, need Fronius Ohmpilot, and it is recommended that you also implement this with integrating temperature sensor. And then, of course, you would need a heating rod that's already installed in the boiler. Good. So once that is done, then, of course, you are set. And just to give us an overview of how this works, so let's say we're generating a 1.5 kilowatts, and then 1 kilowatt goes to the base load. You would have a surplus of 500 watts, or 0.5 kilowatts. So instead of feeding this into the grid, which will eventually cost more when you want to use it back, you can actually use this 500 watts to heat or boil your water. And then, of course, the Ohmpilot basically communicates with the inverter. So the inverter, via the smart meter, of course, tells the Ohmpilot that, hey, I have 500 watts extra energy. Let's now use this to boil hot water. So this 500 watts now comes, and then this is now used to activate the heating rod that is already installed in the boiler. And then this now hits the hot water in the hot water tank. Hits the water in the hot water tank, basically. Yeah, so that's basically an overview of how this works with, of course, all the required components for it to function. So in terms of mounting, we recommend at least a minimum of 20 centimeters gap or space between the Ohmpilot and the inverter, and then a maximum distance of 5 meters. You can, of course, look at the illustration on how to install the Ohmpilot. So in terms of wiring, it's also straightforward. We have the connections for the single phase and three-phase connections. I want to inform you here, of course, as you can already see from the single line diagrams, the line 1 is actually connected to a variable load, as you can see, so technically called a rheostat. So what this does is to automatically vary the power that that passes through. So I'll just use this to explain how this works. So let's say, for example, you want to you have 2 kilowatts surplus power to heat the hot water with. Okay, so what this does is to automatically adjust this such that only 2 kilowatts will be used to heat the water. Okay, so that's for single phase. Now, in the case where you're using 3 phases, of course, this would be wired. Okay, so once they're wired, it will now be connected to the 3-phase heating rod. Now, what this does is, in a case where you need or you have 5 kilowatts of surplus power for hot water generation, what this does is to automatically trigger or turn on this multifunction relay, and then this contactor now connects. So each of these contactors 3 kilowatts capacity. Okay, so for 5 kilowatt, what this does is to connect this 3 kilowatts weighted contactor. Once this is done, it now adjusts this to 2 kilowatts. So 3 plus 2 gives you 5 kilowatts. So that's how you have 5 kilowatts. If it is 6, of course, this now goes to the maximum, which is 3, and then you now have another 3 here. Then that makes it 6. In the case where you need, where you have 8 kilowatts surplus, it will definitely be the triggering of both contactors here to give us 6 kilowatts plus an adjustable 2 kilowatts from this adjustable output or rheostat here, and then that now gives you 8 kilowatts. So that's just basically how the heating works, and of course the power selection from the Ohmpilot. Good. So in terms of communication, Modbus communication, please ensure that once you're wiring, ensure that on the smart meter, the D plus and D minus switches are off, because if they're on, they're going to intercept the communication because of the terminal resistors. Because this, of course, activates a terminal resistor of 120 ohms. Okay, so for a complete communication loop, there has to be terminal resistors at the ends of the communication devices. So in this case, it's the Ohmpilot and the smart meter. So in order to achieve seamless communication, only the terminal resistance, the Ohmpilot and the smart meter should be on, as you can see in this case. If there's any resistor, the terminal resistor that is triggered in between this loop, it is going to automatically intercept that communication line, and then you would have no communication between the Fronius, Ohmpilot, and the smart meter. So just making that note here. For heating rod specifications, like I mentioned earlier, it is it is recommended that we have for single phases 300 to 3 kilowatts heating rods, for 3 phases 900 to 9 kilowatts heating rod, with availability of a neutral conductor, and of course the integration of bimetallic strip or thermostat. So while for wiring two heating rods, of course, it is essential to take note of these. So what happens is that there is an extra connection. I think I better go back to the previous slide to show you. Yeah, so this terminal 11 here, it says multifunction relay output. So this is what is used to trigger any external heating device per se. So That's it. So once you have two heating rods, say a single and a three-phase heating rod, you can easily connect it this way. So the second heating rod will be automatically be switched in by the use of the internal switching relay, so long as you have done the wiring of terminal 11 from the previous slide, like I showed you. Good. So if we're making use of two three-phase heating rods, then it would now be necessary to implement an external switchover contactor that would convert the output from single phase to three-phase. So therefore, you can now achieve two three-phase heating rod system. And this is where you can actually implement the up to 18 kilowatts heating system, thereby having 9 kilowatts to 9 kilowatts heating rods. So that's basically the explanation of how you can achieve 18 kilowatts hot water generation using two three-phase heating rods. Good. So going further, you can also implement or complement the system by adding a smart grid ready heat pump. This is also connected on terminal 11, as you can see, using the multifunction external relay. So talking about the commissioning of Ohmpilot, yeah, before we delve into that, you would of course have to start up from opening or accessing the access point. And then before we do that, let's just simply quickly take you through the features of the Ohmpilot, physical features, as you can see. So we have the power symbol, the communication symbol, and then the alert symbol. So for the green LED, that is this, so that basically gives us the status of the Ohmpilot. The blue LED gives us the communication status, while the red LED, which is aligned with the alert symbol, tells us there is an error. So basically, if say there's some sort of wiring error per se, so this LED comes on to tell you that there's a sort of a mistake in the wiring per se, just as a reference. So in order to open the, or to have access to the access point, there is a button located just beneath the indicators. Yeah, so we use this push button to gain access to the web UI of the Ohmpilot. So what you need to do is to press it once. So once it is pressed once, that basically opens up the router. And then once this is done, you can now be able to have access or communicate with it. And then once you press it twice, you'll be able to open the access, open up the access point normally. Once you push it thrice, this basically is what I would call a manual override per se. So because once you push it 3 times, it triggers the Ohmpilot to use the grid to generate hot water for about 4 hours. Yeah. So after having access to the web user interface, the access point, I mean, next is to connect your monitoring device. So this could be your tablet or your laptop. Log on to the web user interface by the use of this IP address, 192.168.250.181. So once this is done, you'll be able to have access to the web user interface of the Ohmpilot, where you're going to see the status, the temperature, and then the heating output, that is, if it's already connected. Yeah, so it will indicate if you have a second heating element also. And then of course indicate if you're using a 3-phase heating rod or not. So you basically get all the basic information about the Ohmpilot. That's for this particular tab here, for the Ohmpilot tab. So going to the general tab, here you can configure it indicating if you're using a single phase or a three-phase. And then you can also configure if you're using the manual mode. If you're using the manual mode, you can, of course, program how long you'd want it to operate and the minimum and maximum temperature you'd want it to achieve, as you can see. It's also possible here to activate the external heater. That is, if you're using more than one heating rod. Good. So next up is to show you that you can actually connect your heating heat pump, your SG or smart grid ready heat pump. So there, ensure that you input all the necessary information, like your feeding threshold. If feeding threshold simply means if your surplus generation hits 3 kilowatts and above, that automatically turns on the heat pump. And then if your base load hits 500 watts, it will serve as the switch off threshold for the heat pump. So in terms of network, like I said earlier, you can actually make use of both LAN and the wireless LAN, otherwise called Wi-Fi. So for the LAN connection, of course, it's basically straightforward by the use of your hardware Ethernet cable. And then if you're going for the wireless LAN, all you need to do is to search for it, and then you'll be able to connect to it automatically. But in all these cases, please ensure that you save all your settings. Once you do so, that would ensure the connection of your Ohmpilot to the system or network. Good. So with that, I have come to the end of my part of the presentation. Byron will now be continuing by telling us about the e-mobility solution that can be implemented by the use of the Fronius Wattpilot. Byron?
Thanks, Cyprian. So next we'll be discussing the Fronius Wattpilot. So the Fronius Wattpilot 2.0 is available in two different variations. So we've got our Fronius Wattpilot Home, which is available in 11 kilowatt and 22 kilowatt variant. So this allows for 400 volt three-phase or 230 volt single-phase charging. It's available in two different variations. So the 16 amp is locked to the 11J, which is the 11 kilowatt variant, and 32 amps on the 22 kilowatt variant. The unit is IP rated at 55, so it can be exposed to some elements in a sense. The other version is the Wattpilot Go. So this is available also as a 22J and 11 and 22J, which allows for a CEE or sector socket. So it's a 16 amp socket itself for the 11J and a 32 amp for the 22 kilowatt variant. Both units are also rated at IP55, which means allow them to be exposed to some of the elements in the natural environment. So dynamic control with the Fronius Wattpilot. So this is where you'll have your originally existing Fronius inverter with its Modbus communication to its Fronius smart meter, which is on the feed-in point. Then the Wattpilot will then be integrated into the system on the AC side, and it will then rely on communication via Wi-Fi or WLAN to then communicate via a solar API protocol between your network and the Fronius Wattpilot itself to then allow for the communication between the two units. So on standard delivery, so what is included when you are purchasing your Fronius Wattpilot? So you will receive a mounting bracket, which is including the screws in order to mount it, as well as the Wattpilot itself. You'll also receive fine wire fuses, which are replaceable. So this is in case there is a fault with the unit or it triggers the fuse to be tripped. You can then unscrew the fuse from the back of the unit and then simply replace the fuse itself. Also, what's included is the metal bracket for anti-theft. So this allows you to put a padlock through the metal bracket to allow for anti-theft, so from anyone stealing the unit itself. You also receive an RFID reset chip. So if you need to reset the charging mode on the Wattpilot itself, you can simply use it by the RFID reset chip itself. You also receive an ID chip. So this is for the identification chip of the Wattpilot itself. You also get included is your quick start guide on how to set up the Wattpilot, as well as a quick commissioning guide with the Wattpilot. You'll also have to make use of the Solar Wattpilot app, which is a free app to use, and this will allow you to do full configuration of the Wattpilot. You also get optional accessories, so you can do an additional mounting plate, especially for the Go variant, which is a portable variant of the Wattpilot. You also can have a Type 2 cable delivered with the unit as an optional extra. So this is available as 2.5 meter, 5 meter, and 7.5 meter cable that is provided by Fronius. So this allows for 32 amp or 22 kilowatt variant. You also get a cable suspension, so helping that the cable does not get twisted or damaged in any sense. You also receive 10 ID chips to allow for the unit to be used. So if you've got 10 personnel in the company, for example, you can order 10 ID chips, and they can then make use of the Wattpilot to then charge the EV vehicle. You also have the adapter set for the Go variant, which includes the different plug configurations. So you get a CE red, so this is a 16 to 32 amp rated plug, or a blue CE, which is 16 amp, or you can also have a Shoku, which is a 16 amp plug variant. So for home installation for the Wattpilot, what will be needed? So you'll need a Type A breaker, which is rated at 30 milliamp, and then you'll also need a circuit breaker with it. You'll then have to make use of your Shoku plugs, so either 16 or 32 amp, or make use of the connection socket for the Wattpilot home variant, as well as having a Wi-Fi repeater if it is too far from your original existing router. So with e-mobility and PV, so this is the different control options with PV itself. So for this example, we are using a 5 kilowatt peak PV system, which is then charging an 11 kilowatt hour from 4 o'clock in the afternoon on a sunny day. So without intelligent control, we have a self-sufficiency of 30%. So as you can see is the normal consumption of the household itself. And then we have this massive peak here in the self-consumption, which is then of the charging of the EV vehicle, which then gives us a basic self-sufficiency of about 30%. If we are doing night charge, so this is with you relying on your main charging to be done overnight, with the control of Fronius Inverters, the IOs, so the inputs and outputs control. So this will help give us a self-sufficiency of about 60%. If we are then using Fronius's dynamic control with the Wattpilot itself, so this relies on us using good self-management of our loads itself and using PV surplus to help charge our EV vehicle. So this will help give us a self-sufficiency of about 90%. So we're only relying on that last peak of the charging to be done by the grid itself, which then helps give us that 90% ratio. So controlling via Fronius load management. So this allows us to do the inverter activates a socket or wall box in case of PV surplus. So this is known as our PV point, which is available for the Gen 24 series. So this allows a minimum capacity protection, so it allows for the night charging itself. And we can also do a manual switch or button for allow for instant charging. Again, mentioned you can have it either a single phase or 3-phase connection is possible with the Fronius Wattpilot. Charging with the Fronius Wattpilot. So we have easy charging. So this is charging with a present current. So if, for example, it's 16 amp fixed, for example, or the customer can choose the current level through which they want to charge. So they can either do it slowly and gently or as quickly as possible. So it all depends on your personal preference for charging your EV vehicle in that sense. We can also have surplus or flexible electrical tariffs are not taken into account in this charging with connection is necessary with this. So on the Wattpilot itself, we have a button for setting the current range. So it will start at either 4 amps or go up to 16 and 8, for example. And this is a good indicator on showing the available amperage that you are charging your EV vehicle at. So this is why we make use of the LED ring. So with the Wattpilot, there are different charging modes that are available. So we've got our eco mode. So the eco mode is a combination of your PV surplus and charging with variable energy tariffs. So this allows for higher self-consumption rates, or the PV, as well as faster amortization and cheapest energy for the electrical vehicle itself. So this allows for us to be an affordable and environmentally friendly charging with the variable energy tariffs. So even if there is no PV energy, the electric car can charge the most cost efficient over the night with the variable energy tariffs. So this is to set up the desired electricity price thresholds for charging with the app. So with it, it's then possible to charge it at the cheapest rate itself, or even negative charging rates for the EV vehicle. The available energy tariffs with SOS, so it's Lumina and Storm for the Dutch market, or for the AWA2 for the Austrian market. So again, this is only available in markets where there is a variable tariff that can be used, so that you can make use of your Fronius Wattpilot to then charge your most affordable in that sense. You can also fill up on your own solar power. So this is when you're making use of your PV surplus charging. So this is an intelligent use of your energy surplus rather than feeding it back into the grid as wasted energy in that sense, if you are not being billed or do not benefit from feeding back into the grid itself. So the charging process can be controlled in single amperage steps. So the use of the PV surplus, for example, from 1.38 kilowatt all the way to 22 kilowatts. And again, it's a fully automatic, so it can switch between the single phase and 3-phase switch over when doing a PV surplus charging. The next mode is next trip. So the Wattpilot charges a defined distance, so converted into kilowatt hours, into your electrical car. So primarily the PV surplus energy or variable energy tariffs are used from the grid itself to ensure charging the e-mobility car is always charged with the desired amount of energy, even if there is no cheap electricity available. So this is where, for example, we are saying that we need 30 kilometers to get to work and back, for example. The Wattpilot will do a conversion into kilowatt hours of what is then needed, and it will make sure that that electricity charge is available in the vehicle by 6 o'clock tomorrow morning, for example, when you need to leave to go to work, for example. The next mode is surplus charging and how it works. So this is part of the next ride and eco mode. So it defines the threshold valued for the start of the representative charge. So it's single phase or 3-phase. So this allows for the switching between the single or 3-phase charging is possible again. So the regulation possible of in 1 amp steps. So it's 230 watts for single phase and 690 watts over the 3-phase. So here, for example, we can see that the minimum charging power available is for the current charging rates. So it's 8 amps. So we've got 1.84 kilowatts. And then for 3-phase, it equates to 5.52 kilowatts that is available for on the charging itself. So again, it will automatically switch from single phase to 3-phase when it is doing this phase charging. With the Wattpilot, how does it integrate into SolarWeb? So the features on SolarWeb with using of the Wattpilot, so you get the integration is normal, so you can have it added manually to your system itself or delete it. If you're selling the vehicle with the Wattpilot, for example, you can simply delete the Wattpilot from your solar system on SolarWeb. We can also do energy balance analysis. So this is if you have multiple Wattpilots, it is then summed up. So you can have a full detailed view of what exact energy balance we are drawing and discharging from the Wattpilot itself, as well as on our bubble chart. So this is our main chart that normally sits on the left-hand side. So the Wattpilots are displayed separately in the consumption list itself. So you get a full detailed view of how exactly your Wattpilot or Wattpilots are performing in your system. We can then also do under the history chart. So we can do it full detailed values will be visualized separately. So if you need to backdate on how exactly your Wattpilot was performing for last week, for example, you can always go back and view those detailed values separately. You can also still make use of the report functionality. So if you're doing a detailed report for a client that has a Wattpilot connected, you can then do a full detailed report with the Wattpilot's data on your normally daily, monthly, or weekly reports that are outputted to your client. So this is how it will then be displayed in SolarWeb itself. So here we can see this purple sector here is where we are making use of the Wattpilot itself. So you can see here by this graph, we are fully self-sufficient in a sense, and we are still able to draw some power from the grid as we are pushing back to the grid and still making use of the Fronius Ohmpilot as well as the Fronius Wattpilot itself. So with the use of the Solar Wattpilot app, so this is for the app that's used for commissioning and detailed view of the Wattpilot itself. So the connection is via the access point or the integrated network. So very similar to how you would connect the Ohmpilot or the Fronius inverter. It creates its own access point to then access into the app itself. This will then allow you to do the commissioning wizard of the Wattpilot app, as well as visualization. So if you need to quickly see how the Wattpilot is performing, you can quickly go into the Solar Wattpilot app to view a full detailed view of how the vehicle has been charged and how it is performing. You can also do setting options. So if you don't want to manually go and change the current modes that you are charging at, you can also do it via the app itself, and then access from your Wattpilot from anywhere around the world. So if you're at home, for example, and you need to see how a vehicle is being charged at the office, for example, you can simply view that data via the Solar Wattpilot app. Again, this is available in all app stores, so the iOS and Android capability is there. So with the Wattpilot app, it allows us for easy commissioning, as well as the monitoring of the system itself, and also to change the charging modes. So we are constantly updating the Solar Wattpilot app to accommodate for new EV vehicles that are coming onto the market. So with a detailed view of how exactly the car needs to be charged, for example, at what current it can be charged, and for how long, we take that data into accommodation with the Wattpilot app. So next point is system prioritization. So the prioritization of consumers. So this is the solution with battery and the Ohmpilot itself. So here we have a Gen 24 Plus with a Modbus communication to the BYD battery box that we have in this sense. Its system is three-phase, so we have a Fronius Ohmpilot connected to the system, which is then charging or discharging PV surplus back into our heating of water. And then lastly, we have our Fronius Wattpilot connected into the system, all relying on one single smart meter in the system to allow us to monitor fully what the system is doing relative to the grid connection point. So the prioritization will always be the battery is our main priority. So the battery will always be made sure that it has a 99 SOC, for example. Then next will be our Ohmpilot, which is in our second priority. And then lastly is the priority of our Wattpilot itself. So this is the step-by-step priority that the Fronius inverter will then ensure that it is carried out during the day if you have a battery connected, as well as the Ohmpilot and the Wattpilot connected in the system. So next is the configuration of priorities of the inverters or the Wi-Fi access point. So you've got the web interface of the Gen 24. So we'll log into the inverter itself and under load management. So here we can see the load management priorities. So if, for example, our battery is first, for example, Ohmpilot is second, and then load management is last. Next is load balancing. So load balancing, so this is when you can make use of up to 3 Wattpilot devices in one system. So it protects the house connection against overload. So what happens is the system will simply reduce the amount of available current. So we'll only draw 15 amps from each Fronius Wattpilot when the maximum available current is 20 amps. So this is when we have 10 amps directly from the inverter itself. So each Wattpilot must be paired with the same inverter, and the Fronius smart meter must be at the feeding point and not a consumption meter in this sense. And then you also have a cloud solution. So in case of internet failures, it has a fallback mode that the Wattpilots will then fall back against. Next is dynamic load balancing. So this is when we make use of the Fronius inverter. Again, typical connection point with the Fronius smart meter itself. And here we have a base household loads of 16 amps. And we have a connection point of 32 amps, which means we are drawing directly as 16 amps through the first Wattpilot and no availability on the second one. If we then introduce another vehicle into it, it will then be set to 0 to start, and then it will simply shift the available current over both Fronius Wattpilots. So we then are drawing 16 amps from our normal household loads, and we are then splitting it into 8 amps for the single one, and then 8 amps over the next Wattpilot Go in the variant. If we are then having 8 amps that is available through our PV generation, we can then have it split that it has 12 amps through each Wattpilot itself, as still as covering our household loads of 16 amps. If the household loads then increase to 20 amps respectively, it will then shift down the Wattpilot's available current to 10 amps each in this example. So next is again on the prioritization. So you can be assigning priorities as the desired priority can be set for the connection boxes. So such as charging stations with higher priority get power when lower priorities have to wait. So you can do an order of priority. So you can do low, medium, and high, for example. So this is for on the different charging modes. So eco mode, next trip, and standard mode. So high priority will be next trip mode, for example. Eco mode will be the lowest priority, and standard mode will be our next medium priority in that sense. So if, for example, our high priority has then left or has finished charging, it'll then be shifted to share the 32 amps that is available over the next 2 Wattpilots to then charge the EV vehicles. If lastly, there's 1 Wattpilot available in the system and we have a connection point of 32 amps, then the last priority will then be given the full available amperage to then charge the EV vehicle. Next is some application cases. So we've got multiple charging stations. So this is when you have several Wattpilot boxes can be operated in parallel or in standard mode itself. So this allows for PV optimization can only be used by a Wattpilot at a time. So this is when we have a PV controlled Wattpilot and a normal household connection of 32 amps. So if we have assigned a 16 amp fixed rate on the next Wattpilot, it'll then be deactivated the PV optimization on Wattpilot 1, and then it will activate the Wattpilot 2. Example is the eco mode. So then lastly, if the first Wattpilot is done charging, then it is shifted to the next Wattpilot that is available in the system. So next we'll talk about Wattpilot with external sources. So this is if you have a third-party inverter and you still want to make use of a Wattpilot in the system, you'll then need to require a Fronius Data Manager box, which then will help communicate via a network either through Ethernet or WLAN through Solar API. It will then have a Modbus communication to a Fronius smart meter that is in the system, which will then help us monitor the grid connection point, and then we can then make use of the Wattpilot in the system. For further information, recordings are available on our homepage, so you can also view our operating installation instructions, which is available on fronius.com, or on our YouTube channel. We've got how-to videos and installation videos regarding Fronius, as well as webinar recordings, and we have a dedicated Sub-Saharan Africa playlist for any topics related to the Sub-Saharan Africa region. So for your Fronius Energy team, for any technical questions, you can contact the relevant information, as well as for organizing trainings, for any sales international support, and as well as any after-sales services. The details are as followed. To contact Cyprian Okulu himself for the TSA Western African region, you can then contact Cyprian himself, or myself, Byron Kutzer, for the Southern African region, as well as David Mongi for the Eastern African region. That is all for today. Thank you much for attending today's webinar.